Hello, welcome back to Employability Improvement Training for fresh graduates on Information Technology. My name is Ramachandran. I am from Buffalo Industrial Technology Research Institute. In the last video, we saw that fresh graduates out of engineering colleges in India lack employability skills. They do not have enough technical skills, analytical problem solving skills to apply their theoretical knowledge in for problem solving and higher order thinking skills. So what do the employers mean by all these things? What do they mean when they say an engineer does not have skills to apply his theoretical knowledge for problem solving? And what do they mean when they say our learning process is oriented towards low order thinking skills such as memorizing and writing exams? Let us consider this example. It is easier here to learn integral calculus without realizing that integration over a limit gives the area under that curve. You can learn integral calculus, write an exam, get more than 90 marks without even knowing integration over limits give an area under curve. In fact, many of the engineering students do this. They neither learn this at school where they really start learning integral calculus or during their engineering course. They just learn how to integrate various functions, and the questions on examinations are also about integrate x over dx and something like that. So they just mug up integral x dx equals x squared divided by 2 plus c. Go and solve some problems in exam using this formula and manage to get more than 90 marks. Assume such an engineer is given a problem to find out area under a curve over some limits. Though he knows integration very well, how to do integration over limits, he really doesn't know how to solve the problem. He cannot connect. He has to do integration to solve this problem. This is what employers really mean when they say our learning processes are oriented towards lower order thinking skills, or when they say the engineers do not have enough technical skills, or they do not have skills to apply their theoretical knowledge for practical problem solving. Let us take a typical engineer in IT industry. A final year student or a fresh graduate starts attending recruitment processes. He starts with a written test. With his theoretical knowledge, he is able to clear that. Then he proceeds to interviews. Luckily, in interview, he was asked questions which he knows well. Then he was given an offer. He joins the company. After joining, he was given 3 to 4 months of their in-house training. After completing his in-house training, he is being assigned to a project manager. The project manager has a project running. That project consists of many modules. Since this engineer is fresh from college, he assigns him a simple module. Since it is a very simple module, in his view, he assigns this engineer to that module and expects him to complete it independently. That module itself is really simple. The engineer implements it by working very hard, but at the time of integrating it with other modules, he faces lots of problems. He may have perfectly implemented a solution which works when executed independently, but when integrating with other modules, it is not working. There are many problems. An example could be he has used variables with wrong scope without even realizing it. He needs a lot of help in integration and debugging it. Somehow with lots of help, he was able to complete the project. So at the time of appraisal, the manager gives him needs improvement rating. Now the engineer is not happy, the manager is not happy, and the manager goes on to claim that fresh engineers from engineering colleges do not have enough skills. See, this is a typical case. I think more than 70-80% engineers are in this situation in their first job and first project. The employers' complaint about lack of employability skills in fresh graduates is exactly the same. In this training, we will keep our focus that higher order skills To learn this higher order skill, we will not have to do lots of additional effort. While learning any fact, we will try to understand why it is like that, what is the reason for it, how it can be applied, and things like that. At the time of learning each and every technology fact, you will find that you have not spent any additional effort. In fact, it is easier to learn things this way rather than the other way where the focus is on lower order thinking skills, where you will have to do lots of memorizing without understanding. When you understand and start appreciating the high level view, you will find that remembering lower order details will be very easier. We will start our course with an introduction to microprocessors. The reason is microprocessors is the place where most of the key things in a computing environment happens. It is sometimes called as the heart of a computer or mind of a computer. We will start our course from there. Then we will go on to computer organization and architecture, how a computer is organized, what are all the different modules in it, what are the roles of each of these modules in providing a complete computing environment. Then we will move on to the software part. We will learn about operating systems, how it provides an interface between the computer and the user, what are all the different modules in it, why each of them are required, how they work, stuff like that in brief. Then we will learn about how a computer boots when powered on. Then we will learn about program execution environment and process space. This knowledge, in my view, will give you lots of understanding later on when we see various features of a programming language. Then we will have an introduction to various types of programming languages. Then we will learn about C development environment, since C programming language is what we are going to use in this course. Then we will move on to learning C programming language in detail. After completing the programming course, we will learn about computer networking in detail. We will come back and learn about operating systems concepts also in detail. We will learn about microprocessors also in detail and learn about latest advancements in the field of microprocessors. We will come back and learn computer organization and architectures also in detail. After completing those, we will learn data structures, Linux network programming, and we will see an object-oriented programming. We will learn about Java programming. Then we will try to do a project. We will try to do a non-trivial project where we can apply many of the programming skills we have acquired in the previous classes. After completing that, then we will try to get some introduction to the latest technologies in the information technology field. We will learn about cloud computing, big data, and software-defined networking, which are the latest technologies in computing, big data applications, and networking field. When you complete this course, I hope you will have well-rounded knowledge to be able to be employed in most of the product companies in India that I know of. I'm sure you will find this interesting, and from next class onwards we will move on to technical training. See you in the next class. Thank you.